Hello friends. So today we are going to start another problem. This problem is a part of Newton's laws of motion. You can solve this using Newton's laws of motion. Okay, so let's start now without wasting time. So this is the problem statement. Find the acceleration of the block of mass m. Pulleys and strings are massless and all surfaces are frictionless. Okay, so what you see in the diagram is there is a mass with 2m and there is a mass value m, and this is on an inclined surface theta, right? So what will happen? Let's analyze the motion of this system. We are seeing that this is heavier mass, right? This 2m is a heavier mass, and this m is lighter than this 2m. So what will happen is this 2m mass will start going downwards, and because of that this smaller mass m will start sliding up, right? So that's it. There are the only two motion in the system. This triangular block, you can assume this is fixed to the surface, surface or basically ground. So this will not move. Okay, and this is already hook is already fixed. So now let's solve this. What is the approach we follow? We'll have to draw free body diagram of each of the system, and then we can balance the forces using Newton's laws of motion. So let's draw the free body diagram of draw the free body diagram of 2m, right? How it will look like? It will look like this. So this is mass 2m, its weight will be downward, which is 2 mg. Let's assume acceleration is a, right? So what will happen? Let's say acceleration of mass m, the smaller one, is a. So what will be the acceleration of this bigger one? If you observe carefully, you will see that there are two ends to this pulley, right? If this moves upward by a distance x, this part will move by half of its distance, right? So let us say if this moves up by uh, a distance of x up to this, let's say, what will happen is this will come down by how much? Some distance, let's say, some distance, right? So this string x, this string up to this x length should be covered in both of this, right? Because the string is not stretchable. So this should be x by 2 and then this should be x by 2, so that this descent of this pulley is x by 2. So that this whole length of the pulley will become x. Getting? So if there is a displacement of x of this block towards upward, the displacement of this pulley downward will be x by 2 because there are two ends. The string is wrapped in the two ends of this pulley. So this pulley will descend by x by 2. Then only this whole string will move by x, right? So similarly, if it has an acceleration a, then this will have acceleration a by 2, right? Because acceleration is nothing but dv by dt, and then dv by dt is nothing but dx by dt, rate of change of displacement. Okay, so that's the important thing you need to think of. I have tried to explain this my best here. So this acceleration will be a by 2. Okay, now what is, let's say, the tension. let's say the tension in this is let's say the tension in this is T, this part. If this is the tension, then this tension will go upward, right? So these are the only two force I am seeing here, tension upwards and weight of this block downward. So for vertical equilibrium of mass 2m, let's apply the Newton's second law from Newton's second law. Actually, there is no equilibrium here. There is a motion, right? So you should not call it equilibrium. That is misleading term. So I'll delete this. From Newton's second law, what is this? Net force equal to mass times acceleration. Let's say the net force is downward. So total net force is 2 mg minus t upward equal to 2m mass times acceleration, right? This becomes t equal to ma minus t equal to ma, and let's bring 2 mg this side, right? Or t equal to this side and then this side, it will become 2 mg minus ma. Okay, so this is equation 1. Now let's consider the free body diagram of this smaller mass m. PD of m. So let's wait that before we go to the m. Let's consider the free body diagram of this pulley. One important thing I'm going to show you: FBD of pulley. Pulley is like this, right? There is a string attached this side and then two strings going like this. So since pulley is massless, right? Though this is also going by n with an acceleration a by 2, its mass is 0, right? So let's assume that this is t dash, both side of this is having t dash, and then t this we already know, right? Because this same t is being pulled up, it is pulling to the mass 2m also. So this way if you 2 t dash, let's not 2 t dash, let's assume t going downward, right? T going downward minus 2t dash upward equal to mass is 0, time acceleration which is 0, right? It means t equal to 2t dash or t dash equal to t by 2. So what it is saying is, if the mass pulley is massless, then this tension will be half half in the above part, right? So this is become this is now t by 2 here, and this also in the t by 2 here. If it is t by 2, this will also become t by 2 tension this string, because this pulley is also massless. So this and this will remain the same. So now let's consider the free body diagram of smaller mass m. FBD of m. So it will look like this. This is an inclined plane theta. This is kept here. Is its weight mg will be downward, normal force upward. Then there is a tension T by 2 now, right? We just found that T dash T by 2. That's it. These are the only three forces I'm seeing here. Any other force in the diagram? I don't see any other force. So let's break it down. Break it down in this along the inclined plane and perpendicular to the inclined plane. Uh, Perpendicular to the inclined plane, if you see, there is no acceleration, there is no motion. Only motion is along the inclined plane, right? So we'll break this forces down in this plane, let's see this. So if this is angle theta, this angle will become 90 minus theta. If this is 90 minus theta, this angle will become theta, right? So this mg will have a component mg cos theta this direction, and then it will have an mg sin theta in this direction, right? So apply Newton's second law along inclined plane. If you apply Newton's second law, what we found is acceleration of this is a, right? So let's say the net force towards upward is t by 2, and then in opposite direction we are seeing mg sin theta will be equal to how much? Mass time acceleration. That's it. In vertical direction also you can be have a component equation, but that will not needed here because you will get n equal to mg cos theta, right? Which is fine. You don't need n right now. Now t you have already found out, right? T is 2 mg minus 2 ma. So put value of t, you will get 2 mg minus ma by 2 equal to, let's bring mg sin theta this side, ma plus mg sin theta. If you solve it, how is what you are going to get? 2 mg minus ma equal to 2 ma plus 2 mg sin theta. Now it's easy to solve, right? And bring ma this side, you will get 3 ma, and then bring it mg sin to this side, and take 2 mg common. You will get 1 minus sin theta. You can cut out. So a will become 2 by 3 g 1 minus sin theta. So this is the acceleration of smaller mass m. Acceleration of mass m. What will be the acceleration of this bigger mass 2m? This is just a by 2, right? Acceleration of 2m is a by 2. So that will become 1 by 3 g 1 minus sin theta. That's it. Okay, interesting. So what did we learn here? Let's do a recap. What we learned here is, if there are, you need to observe the system carefully. If there are strings which is wrapping multiple times, right? In this situation, this string is wrapped here this way. So because of this, the motion is a little different. Acceleration, tension, and all are little different, right? It is acceleration is also reducing, tension is also reducing. Those sort of things are happening. So whenever you see a system, just observe what will be the acceleration and tension in those systems. Okay. So that's it for today. I hope you learned from this problem. Keep commenting if you need to know, or if you want to me to make any other video or any specific problem, just write in the comment. And then don't forget to subscribe and like this video if you found it beneficial. Okay, thank you. We'll see in the next video.